Welcome back to my channel, everyone. Today we are going to do Kuta software calculus differentiation using chain rule. So what it looks like is you have a function within an outer function. So when you derive, y prime would be the derivative of the outer function multiplied by the derivative of the inner function. For example, in number 1, the derivative of y, which is y prime, equals. Let's derive the outer function, which is the power. So deriving the outer function, I multiply by 5, leave your inner function intact, and reduce the power by 1. That's using the power rule. Now we multiply by the derivative of the inner function. So that would be 3x squared. That's all because derivative of 3 is 0. Now we just simplify by multiplying the 5 with the 3x squared, and you have 15x squared times x cubed plus 3 to the 4th power. Let's do number 3. Once again, power rule first. Multiply by the 3, negative 5x cubed minus 3, your inner function stays the same. Reduce your power by 1, so it's 2. Now multiply by the derivative of the inner function. So using your power rule, negative 5 times 3 is negative 15x. Reduce your 3 by 1, it's 2. Derive negative 3 is 0. Now we multiply the 3 with the negative 15 to get negative 45x squared times negative 5x cubed minus 3 squared. We'll try number 4. Derivative. Use your power rule, so 4 times your invisible 1 is 4. 5x squared plus 3, that doesn't change. Reduce the 4 by 1. Now multiply by the derivative of the inner function. 5 times 2, that's 10x. 2 minus 1 is 1. Derivative of 3 is 0. Simplifying, 4 times 10x, 40x, times 5x squared plus 3 cubed. In number 5, we should rewrite this in exponential form. So I'm going to say f of x equals, change the radical into exponent, leaving negative 3x, 4 minus 2, the same. 4th root is to the power of 1/4. There's an invisible 1 here. So when I derive f, it's f prime of x. Multiply the 1 and 1/4. You have 1/4. Inner function stays the same. You need to subtract the power by 1. So I'm going to do it here. 1/4 minus 1 is the same as minus 4/4. And that should equals negative 3/4. So that's the power. Oops, and I am out of room. So I'm going to erase this so that I have room. Now multiply by the derivative of the inner function. Negative 3 times 4 is negative 12x. Reduce your 4 by 1. And derivative of negative 2 is 0. We need to distribute the 1/4 here. 1/4 of negative 12 is negative 3. You can think of it as negative 12 divided by 4. X cubed, negative 3x to the 4th minus 2, and keep the same power. Let's practice on number 6. We, of course, have to rewrite this. So f of x equals negative 2x squared plus 1. Square root means to the power of 1/2. So the derivative, you got to multiply the 1/2 by your invisible 1. So it's 1/2. Inner function stays the same. And take your 1/2 and subtract 1, which is 2 halves. So that's negative 1/2. Now we have to multiply this by the derivative of the inner function. Multiply that. That's negative 4x to the first power. Simplifying. 1/2 of negative 4x, that's negative 2x. Copy the rest. And we are done. We'll practice on number 7. Again, you have to rewrite this in exponential form. Third root is to the power of 1/3. So deriving that, multiply your 1/3 and your 1. So it's 1/3. Inner function stays the same. Subtract the 1/3 by 1. So 1/3 subtract 3/3. That's negative 2/3. Now multiply derivative of inner function. That's negative 8x cubed. Derivative of 5 is 0. So simplifying, we could actually leave it this way, but if you want, you could put negative 8x cubed over 3 because of the 1/3, and then negative 2x fourth plus 5. One last one. In number 8, it's already in exponential form, so we proceed to derive. Remember that invisible one, we're going to multiply. So negative 2, negative x to the fourth minus 3, subtract negative 2 by 1. So that's negative 3. Multiply by the derivative of the inner function, so that would be negative 4x cubed. Simplifying, the derivative of that would be negative 2 times negative 4 is positive 8x cubed. Negative x to the fourth minus 3 to the power negative 3. Thank you for watching my video, and please leave a comment if you would like to see another video on a different math topic.